So in this next video, we are going to continue with the topic of managing quality. In the very first part, we talked about just the sort of general concept of what quality is all about and some of the different types of definitions and tools that can be used for quality management. So here we were going to learn a bit more about some other tools that we can use to manage quality. So we call them tools of TQM. What are some of those? So let's get into some of these tools. There are many tools, but we're going to take a look at 7 of them. So there's one tool that can be used for generating, a set of tools that can be used for generating ideas, particularly ideas to problems. And what it allows us to do is to gather data and sort of look for a pattern in the data. So check sheets is one of them. Scattergrams or scatter diagrams, if you wish, cause and effect diagrams. I like those two. This particular tool here, the cause and effect diagram. A scattergram allows you to look for a relationship between two parameters, and so if you see some kind of a trend or some kind of pattern in the data, it will show up. And then we have tools for organizing data, such as Pareto graphs and flowcharts. A Pareto chart or Pareto graph essentially is an ordered bar graph. Either you go from low to high or from high to low. And flowcharts, of course, shows us the various steps in a process to accomplish some particular outcome. If we want to identify problems, then we could use things like statistical process control charts, because they allow us to identify when things are out of order, in other words, outliers. And then histograms could also allow us to take a look at the shape and see whether or not we have these extreme values as well. So let's learn a little more about some of those. A check sheet is an organized method of recording data. So in a check sheet, you could sort of just simply create a set of, if you wish, either potential causes or reasons or factors. And if we were to put the factors over here, factor 1, factor 2, etc., and then the occurrences, like, if we conduct an inspection or a situation happens, and these are the different ones, then if the factor that's causing the problem in the first case was this, then we would highlight that. If in the second case it was this one, third case it was this. So now in 5 cases, 3 out of the 5 cases, we had this particular factor. So we might say that we need to, if we could address this particular factor, we will deal with 60% of the cases. But that's a very small sample. If we have now a large sample where we collect data, it will help us to really address the problem in a major way. So you could see how what we're looking at here is an example of a check sheet where we're looking at the hour that we're actually conducting the inspection and what kinds of defects that we're seeing, type A, type B, or type C. All right? And then we will simply add up across the hours and see which one is most prevalent. The one that's most prevalent is the one we should address first. Right? We could actually take the values that we get and then graph them. How many of defects A did we get? How many defects B did we get? How many defects C? So we would just simply add them. So for example, A, we have 4, 5, 6, 7. And then 3, 10. So you have 11. Then you have 2 and 3, 5, and 2, 7, 7 and 3, 10. And then we have 3 and 2, 5 and 4, 9. So you could see defect A occurred most frequently, followed by defect B, followed by defect C. All right. So you could so let's focus on eliminating defect A. All right. So here's the scatter diagram just showing productivity versus absenteeism. Is there some relationship between them? So when the absenteeism is high, you expect productivity to be low. And so clearly it shows that there's some kind of negative relationship between those two. As I was telling you, in terms of a cause and effect diagram, we have the issue that we're trying to address over here, and we want to identify the causes. We could group the causes according to categories. The causes could be methods related, materials related, manpower related, machinery related. Okay, it could be also in terms of policies. Right? It could be other types of resources such as funding, financing related, etc. So, and then if you have aspects of materials you want to consider, whether that is the volume, the quality, the size, the weight, you could put them down here as bones, small bones on the bigger ones, right? Methods, whether or not is it the documentation of the method, is it the actual method itself, is it the amount of effort required in the to use this method. So you could actually come up with a number of factors under each of those. Okay, and we could continue to even make other factors off of these ones. What's the value of that? Well, once you've identified all of the potential factors that could cause a problem, we must now gather data to determine which of those factors are crucial. But you'd go for a brainstorming exercise with a group of staff members to determine which of these factors are most critical for us to examine. A Pareto chart, a graph that is used to identify and plot problems or defects in descending, or it could be ascending order. And the flow chart, as I mentioned, describes the steps in a process. So these are fairly straightforward. So you can see here, this is defect A occurs most frequently, then followed by B, C, D, E. And so if you draw the cumulative diagram, what chances are, if you worked on those two, only those two, we could actually be eliminating a bulk of the problem right there. These two could represent perhaps 75% of the issues. All right? So it allows us to identify the vital few. And of course, a flow chart, everyone understands what a flow chart is, which helps us to essentially map a process. And when we want to do improvement, we focus on the different steps in the process to see what needs to be improved, right? A, B, C, D, E, F, if these are the various steps, then perhaps we could improve the process and improve quality by focusing on E, because there seems to be some issue that's always occurring at stage E. The histogram and statistical process control. Well, I think we're quite familiar with histograms. If the process is functioning properly, then it should look like a bell-shaped curve. But if you turn out and we see now that this is what's happening, then there may be outliers right here, or there may be outliers right here. So you want to actually use a histogram to assist you in identifying whether there might be any particular outliers. Statistical process control is kind of similar to confidence intervals if you've done statistics, where we set upper and lower control limits, and then within those limits we expect 90, if we do free standard deviation limits, 99.73, I believe it is, percent of all of your variations should be in that range. So since there's a relatively small percentage of values that should fall outside of that, when it does happen, we say there's not supposed to be a huge probability of that occurring. So that is an outlier. So outliers represent what we call assignable causes. There's a reason for that, assignable causes. So we need to now go and do an inspection to figure out what's wrong. The variation that we have within the limits is what we call essentially common causes. All right? common causes, things that happen to all the material. But when we see an outlier like this or this one, we say those are assignable causes, right? And now we need to go and do an investigation to determine whether or not a tool broke, whether or not the raw material was faulty, whether or not there was a miscalibration of the equipment, or whether or not someone wasn't well trained. So those would be examples of assignable causes. Cause and effect diagram I talked to you about. So if you look at a basketball game, I presume that is free throws. So what are some potential causes of that? On the method side, your shooting process, the aiming could be off, knees not bended, poor balance, hand position, not very good follow through. On the ball, on the material itself, the grain of the ball, the air pressure, the size of it could be lopsided. Training, manpower, the coaching, conditioning, consistency, motivation, concentration, and then the hoop itself, part of the equipment, the backboard stability, the rim size, the height. All of those can be potential problems. Now you need to go and study and gather data to determine if it is the grain of the ball, then we change that. If it is the issue with bending the knees, then we work on that. If it is the rim alignment, then we fix that problem. But you have to now, knowing what the potential causes are, you need to go and validate which of those are actually at play and work with them. All right? Flowcharts are, as we already said, basically will map a process for us, and they're quite useful. And here's an example of an MRI flowchart. Physician schedules MRI, patient taken to MRI, patient signs in, patient is prepped, technician carries out the MRI, inspects the film. If unsatisfactory, repeat. Patient is then taken to the room. MRI is read by the radiologist. MRI report transferred to the physician. A patient and physician discuss. So you see the various steps there, and this is what the flowchart looks like. And you would use that if you wanted to try to improve the process. Where are there delays? Where are there errors that are typically happening? Where is it that there are lengthy wait times? Sorry. Where is it that maybe materials sometimes are not often available in a timely fashion? So you could study the entire process, find ways to improve it. Okay? Statistical control charts, basically there are different types of control charts to monitor different aspects of a process. You could focus on the process mean or the average of the process. You could focus on the process variation. And depending on if the process is a normal distribution, then we could use the 3 sigma control limits and so on, free standard deviation control limits. But then we do have some other types of distributions, such as a Poisson distribution, exponential distribution, that we'll talk about, that we use for different things. So monitoring a variable is one thing, like the average size of a cylinder, or the average amount of time taken to process a loans application. Or we could be looking at things like the range of time, the variability in terms of the processing times. But sometimes we're interested in something called like the number of defects per unit, for example. So if we were to open up a page, how many typos are there on that page? In that case, we can use statistical process control, but the distribution that we're focusing on is actually a distribution called a Poisson distribution. All right? Okay, so using statistics and control charts to tell you when to take corrective action. And the when to take corrective action is when you observe an outlier. That's when, because that is out of control. Essentially, the control charts really help you to do a hypothesis test based on inspection. Once you set the 3 sigma control limits, anything that falls outside of that are essentially in the rejection region for a hypothesis test. So you're usually hypothesizing that the process is in control, or the process is out of control. So when you now take the data and you plot it and you see an outlier that tells you that you are outside of the limits and therefore the process is out of control and you should shut it down, do an inspection, improve it, and then restart it. Okay? So it drives process improvement. You measure the process. When the change is indicated, find the assignable cause, and that change is really the outlier. Eliminate or incorporate the cause, restart the revised process, and then keep monitoring. All right. So as we could see here, an SPC chart for the percentage of missed free flows. So what happened was that here's the upper and lower control limits for that, based on the statistical data that was collected. All of these points here are within the limits, so we have no concern until we come to this point right here. And then all of a sudden, we are concerned. And so as a result, we now needed to conduct an inspection to find out what the cause of that is. Cause and effect analysis. All right? And then we use the Ishikawa diagram that you saw on the last page. The role of inspection. So inspection plays an important role in quality management in that it gives us data, of course, and then it allows us to determine whether or not we believe a product is defective or not. So it involves examining items to see if a product or good or service is good or defective. Detect a defective product does not correct deficiencies in process or product. It is expensive. So it's basically it's something that we do to determine. It requires effort. It doesn't correct anything; it just identifies when there's an issue. So issues, we have to determine when to inspect and where in the process to inspect. So you saw the MRI process. Do we inspect all aspects of the MRI process, or are we going to focus on one particular area? If the data is showing that one particular area seems to have an issue, then we actually inspect that area more to learn more about what's going on. All right. So what are some places that we could actually inspect? At the supplier's plant, while the supplier is actually producing, to see what might be going on. At your facility, when you receive the goods, to see if there's a problem when the goods are received and put away. Before costly or irreversible processes, during the step-by-step production process, when the production or the service is complete. Now that kind of inspection is not, is necessary sometimes after the product is complete. You would actually inspect it as well. But that should not be your only point of inspection. You should be inspecting all along the entire process itself, right? Before delivery to the customer, you want to do random inspection where you take a subset of your products and then you inspect them. And at the point of customer contact, you can also do inspections there as well. Inspections, the role of inspection would be to help you identify problems. Problems can come from all kinds of sources, such as worker fatigue, measurement error, and the variability in the process. So we have to be able to tell which one of those are actually at play. It cannot inspect quality into a product. In other words, inspection helps you detect, but it doesn't make a product a quality product. It's only after you've eliminated the causes then the product improves. All right? You then should focus on things like robust design, empowered employees, and some processes can actually help with improving your performance. Source inspection, also known as source control, is the next step in the process is your customer. Ensure perfect product to your customer. All right? So the idea when we say the next step in the process is your customer is that if you have a process that you're mapping A, B, C, then B is a customer to A. So make sure that good product is delivered to B. Then C is a customer to B. Make sure that B delivers good product to C. So if we use that approach or that attitude, then that certainly can help with improving product quality. There's a tool that can be used in terms of helping with inspection. It's called a Pokeyoke. I believe I'm pronouncing that correctly. I'm not sure, but let's say Pokeyoke. It's the concept of foolproofing, right? So if you have a product going through a process of steps, you could at different stages include a Pokeyoke that prevents it from actually passing all the way through as an acceptable product. Only the ones that make it are the ones that are acceptable. An example of a Pokeyoke would be, let's say for example, you have an area in your factory yard, but you only want vehicles of a particular height to be able to go there. Or maybe you only want vehicles of a particular height to enter the production facility. But what you would do is you put a bar at the height that you would allow, and anything that is above that cannot go through it. So that's an example of a Pokeyoke. Before you close a document, asking you to save is an example of a Pokeyoke. So you do not have people closing files and not saving them and then end up crying the next day. TQM in services. So we've been talking a lot about products because that's where a lot of the work was done. But it also exists in services, but it's a bit harder to measure because the customer is usually involved in the process itself. And the customer's level of satisfaction influences the definition of what quality is. So it's more difficult to measure than the quality of goods. Goods, we could measure the performance, we could measure, take dimension, if we wanted the size of it, the weight of it, the volume, etc. But in a service, we rely on the customer to give us an indication as to whether or not they're happy. Service quality perceptions depend on intangible differences between the products and services and expectations that the customer has of those products and services, right? So the operations manager in that case then must recognize the tangible aspects of the product or service is important. So for example, if we're running a small business and we're doing car detailing, the kind of polish that's part of the products that's being used in delivering the service, the kind of soap that is used, the kind of water that is used. So all of those things, the temperature of the water, etc., are important aspects in terms of the product aspects of the service that has been delivered, which is to give you a clean, detailed car. All right? The service process is important as well. The steps that are being used, how the actual car is being washed, how it's being vacuumed. All of those things are also important aspects of that service delivery itself. So the service is judged against the customer's expectations, and sometimes exceptions will occur. But the customer will determine whether or not they are pleased with the quality of service that they receive from you. Like product quality, and we identified a number of dimensions for product quality, there are also dimensions for service quality, or determinants if you wish. Reliability. So the idea that a service is particularly is consistent. So if you go to your favorite restaurant, on one day you get really great service, and then another day really bad service. The food may vary if they have multiple cooks, and then one cook decide to experiment a little bit. But sometimes the service that you get might vary because you have a different server. Not all the servers are the same, they're not identical. So the service reliability has to do with the service being exactly what you expect every time, right? So that the dependability of that service. So that's an important one. That's a tough one to control. Responsiveness, how quickly your concerns are actually addressed. The competence of the staff. You've gone to places where the information that you get was not accurate, or that people just simply did not know anything about the product that they were selling. So the competence level is important, or that somebody just messes something up. You bring a plumber in to do some work for you, and the plumber doesn't do it right. An electrician, and then they wire something wrong. So that's competence. Access, how easy it is to approach the service provider, or how easy it is to find them and access them. All right? Courtesy, how they actually interact, the politeness, the respect, consideration, the friendliness, etc. Communication. Basically, how often you keep customers informed, and on the quality of the information that you provide them. And I'll tell you, when it comes to traveling, one of the biggest concerns that passengers have when a flight is late is not knowing why it's late or not having good information as to when the flight will depart. We often want to know when the flight is going to depart, what's the reason, can we actually change our flights while we're waiting, if we're going to be waiting too long. If you're not given information that allows you to make decisions, then the experience is going to be very poor. Credibility. You have to have credibility in your service, that essentially that you're trustworthy and that you're believable, and that whatever you say that you're going to do, you're actually going to do it. So you have to have the customer's best interest, and your word is bond. You have to be someone of your word. So that's extremely important. Security is the freedom from danger, risk, or doubt. And then, of course, understanding and knowing the customer. How well does your service provider understand and know you? That's an important aspect of the service, because sometimes they're able to give you advice. They're able to, without even asking, maybe tweak the service and give you an aha moment because you didn't expect that. But that's because they understand you. And of course, services have tangibles as well. Imagine you taking your car into a service, to get service. And the place that you're given to sit while you're waiting is very dirty, grimy, oily. You're not going to like that. Imagine you going into your bank and the walls are not well painted, the lighting is low, the stationery is not cool. Say customer service representatives are not well dressed. Those are part of the tangibles, and those things are extremely important in terms of our judgment of a service. One of the things that's also important in service delivery is that when you fail, you have to try to recover the customer, and it's very important that not only you deliver good services, but that you have a strategy for recovering a customer. Because remember I mentioned about winners and losers. Well, there are service winners and there are service losers. The same way there are product winners and product losers. So when things don't go quite right, you have to have a strategy in place for recovering that customer. So managers should have a plan when services fail. Listen, empathize, apologize, react, and notify the customer. So you have to, one of the things that is extremely important to do in a case like that is to tell the customer how you're going to compensate them for the error. A lot of companies don't want to do any compensation. They wouldn't offer you a discount on your meal, or they wouldn't offer you a voucher to use next time around, where that actually helps you build loyalty, because you come back and knowing that you'll receive one of those vouchers, hopefully the company goes above and beyond to assist you. So clearly that is something that you have to think about, how you compensate the failure. And then you must let the customer know if there's an error and the customer is not with you, you must notify them of what that error is and how you're going to correct it. All right? So summarizing, quality has many different meanings. We said that already, that quality has to be built into systems rather than inspected in, that total quality management concepts require that you consider the entire organization. You focus on Six Sigma, continuous improvement, just-in-time, Taguchi, benchmarking, employee empowerment, and tools to help manage quality. We just went through 7 tools right there. And so with those, we can strengthen a company's performance or an organization's performance on quality. All right? Even though it is not the sexy thing it used to be in the 80s and the 90s, the reality is that quality is still important, because everyone wants quality and they expect it. So quality is no longer an order winner. It's actually what we call an order qualifier. to qualify to actually do business, you must come to the table with a high level of quality and match existing competitors if you're competing, or meet the expectations of customers if it's a not-for-profit. All right? So remember, quality management is still very much in the forefront of organizational performance.